a little bit to not hit that ball. Trust me, I know. Yeah, I'm still trying to figure it out. But indoor golf helps a lot because I don't have to travel, and you can just turn it on anytime you want, and you can play a lot of cool courses that you have to like travel to all the time.
How you doing?
Good. How you doing?
Good. Kody?
Kody.
Nice to meet you. I'm Trey.
Trey, nice to meet you.
How you doing?
Oh. He says make sure you use the mic.
Yes, I will once we.
There is a mic.
Yeah, for here. Yeah, I've got two of them just in case. I checked it. It doesn't work.
Hey Mike, do you mind if I run the back real quick? Yeah, I can check it one. If I can figure it out. It's super easy.
Yeah. So hi everyone. This is Quad Max. So it's our top of the line launch monitor. We'll talk about launch monitors in the presentation. But it reads a golf ball, where it goes, how far travel, spin, all the important things that you can do on golf ball. But more importantly for us, it connects to the software, and then we can do really cool stuff with that data, visualize it outside of just numbers on a screen. So that's what we're talking about. Numbers.
You do a full intro in the beginning of the presentation?
Yeah, we talk about is there's more than just these devices. We've got some overheads as well.
Okay.
And we also no one here probably knows what a launch monitor is, what that means. So we'll talk about it and who uses it, why it's important. Well, why it's important to them. So yeah, we'll definitely give a nice little launch monitor.
You ever get into parking?
Oh, no. Also, the golf balls on the table in the bag are foam. They're nice little fidgets, so feel free to grab one. They're fun. They're foam. They're hard foam, which I like a little bit better. Requires some squeezing, but yeah, feel free to grab one if you want.
Oh, Mike, are you looking for the
Parking passes, yeah. Sometimes you lose them.
Oh, okay. Because it's like $3 every 20 minutes.
Yeah. I don't even with the validation. I think it's someone said $7, but I think it's more like $8.
I think it's 8. And I verified last time. I got here early, and then I went out with Marcus.
Oh yeah,
And I don't think I left till 10:30ish, and it was just even though it
you want to see? Some says 7. We should change that. I think they it says validation for 7.
Yeah. Yeah, if you parked in the garage, you don't need that.
Oh, okay.
Is anybody writing code anymore?
Orchestrating code.
Just orchestrating? I find I'm not writing code, but man, so I'm trying to get a workflow working where Claude will pick up. So I have a routine. Claude will pick up data out of Sentry to see like what bugs might be escalating, and then it'll file that in GitHub issues, and then prioritize the issues list. And then I have a second routine, wake up 2 hours later, it's all in the middle of the night. It'll wake up 2 hours later, pick up the highest priority issue, and then create a PR for it and get it ready for human review in the morning. So when I come in, I've got a PR for bugs.
We have the same process.
So,
It's really great.
but I'll say like the first 3 shots out of gate. I'm like, no, you can't. Like, did you not?
It's all about the prompt engineering.
Yeah. So I haven't gotten to talk to them.
Yeah. Share. I can share my one.
Okay. The
talk.
talk.
We're broadcasting live, so it's fine.
The talk for FlutterCon that I submitted is basically using Shorebird, who was here last month, using their product to. I want to submit patches all the way.
And then
just go directly to patch, but then because I can ship so quickly, actually use telemetry from Sentry to verify the bug was fixed. That's the full loop.
Do you have enough usage for that?
Yeah.
Cool. That's awesome.
Yeah. I mean, if it's obviously some bugs I would, but not all.
Other ones are like down a flow, right?
Yeah.
That's the challenge, is like down the flow.
Yeah.
But then you just get patrol and just have it go down the flow for you, and then you're all good, right? You don't need the user.
Yeah.
Patrol.
No.
Patrol is like a EDE testing framework built in for Flutter.
Okay.
It makes like finding widgets really, really easy.
Okay.
And interacts with like allow prompts and stuff like that on the native side, and you run them on real devices or device farms. So you can just like write EDE tests that run actual user flows.
And
using Dart, which is great.
How different is that than just the built-in end-to-end testing that Flutter has?
Yeah, I mean, my problems with the integration test package thing is one, like the native prompting, like when it asks for Bluetooth, because like that's our biggest thing here, and then location, like it can't accept that. Okay. So this adds on to that. Also, Control, in my opinion, does a better job at like easier finding widgets. It's like it can use keys, it can use like various other things, whereas an integration test is kind of just low level, if you will. And so like all the build out that they've done on top of that is super cool.
Yeah.
It's made by Lead Code.
I have heard of it now that you mention it.
Yeah, it's pretty neat. So like we have a bunch of these actions like you're talking about. We actually do it in GitHub Actions so that we don't have to have like things just running. And one of them runs every day and just finds low code coverage across our various tests. Like we have units, goldens, EDs, like we've got everything you can imagine.
Yeah.
And then just makes them.
Yeah.
So and then opens PR, and then we have another one that reviews the PR and then approves it, or tells the bot to fix it and it goes and fixes more, which is cool to kind of
It'll
see that
iterate on it.
And then it was like, okay, now request a human review.
That was the first insight I had was, why am I not using the same tooling that I use as a human? Like I was skipping GitHub issues.
Yeah.
Because I'm a solo dev, right? So I was just like letting Claude run, and then basically in the Claude window, just having this whole loop conversation. And then I was like, this is dumb. I don't have any traceability once this thing ships.
Once it's done,
And so I moved everything back to like, I'm going to use the tools all the humans use, and I'm going to push everything into GitHub issues. I have a separate thing prioritizing, like I said, and then I'm working off the GitHub issue.
Yeah.
And then
and then you can have it dump its context or a summary of that into the GitHub issue, right? So if it has to fix something, it can just ramp up.
Yeah.
It's not you're going to spend a whole bunch of tokens getting ramped again, right?
And it does a good job of it'll search existing problems. Like I tell it in my prompt, it's like you've got to search the closed issues list, see if anything like this has happened. And as long as I've got that full context in there, it's great.
Yeah, real quick, I don't mean to interrupt. Earlier you said out of like the first 3 shots, I guess it's inaccurate. Are you referring to, I guess, the PR in the morning that you said you received?
So what I meant by that was the thing I'm having trouble with Claude is it'll confidently say, I found the smoking gun, this is the issue, and it's like 100% confident. But when I look into it, I'm like, I don't know, like, did you know, every single instance, I've been able to look at it and say, I don't think you really found the root cause. Like, I think you're just trying to cover up like the exception or the bug. But like the root cause is actually some code way over here. And so I think its proposed fix in each instance has not been, it's not something I would ship as is, even though it was confident that it found the bug. So I haven't been happy so far with
That's
it.
where the prompt, so prompt engineering comes into play, like what you tell it to do ahead of time, like what you're saying, stuff with a root cause analysis in the prompt is important because it might skip it because it thinks it's not relevant, right? Like my goal was just to solve the code piece. I did that because I looked at this code piece. I noticed it was missing whatever, an if conditional, and it was like, check, I'm good. But like, I wasn't told to go find the root cause. I wasn't told to dig deeper. And some models you have to, right? Opus, generally good at like not needing to handhold it. Those other ones you're definitely gonna have to. And then picking the right model is incredibly important, right? So like that's the other thing is like Sonnet, like solving problems like that, probably not gonna happen well unless it has a ton of context. And that context you gotta give it.
What was the other software you mentioned? Said telemetry.
The Sentry.
Oh, Century. Yeah, I heard. I might have mixed two words up.
I said the words telemetry, but that's because what I've been talking a lot about. So
okay, so I wasn't tripping.
No, you heard the word, but that wasn't it. Yeah, the vendor was Sentry, and then I'm using so with Flutter, and you guys could all relate to this. I couldn't get any of the cloud environment stuff to help me at all because it wouldn't run and build like on an iOS app or a simulator or something like that in the cloud environment. So without that, it's like, okay, you can write the code, but you can't verify it or do anything with it. And then also, I could not, they had shut down like certain services, like in their, Claude Code's cloud environment, you couldn't run like GitHub's CLI. It's blocked. So,
Yeah, I've noticed this. Like you
yeah.
cannot directly add GitHub things.
Yeah.
So it's difficult to.
Right, and then the other limitation is on the back end on one of my projects I use Firebase, and Firebase runs a Firebase emulator suite, which I use locally for testing. I have a whole test suite against that, and it could not run. It's a Java process, I guess, and it could not run Firebase emulator suite. So anyway, I was running into all these problems. I spent 2 days trying to like get through them. And I was like, this is dumb. And then finally, the routine stuff came out where I could run locally. So I'm just like, well, I'm not using my Mac in the middle of the night, so I will just schedule these routines to run locally. And now it can do all this stuff. It can run the Firebase emulator suite. It can do anything I can do locally.
So like when you actually create all these PRs and it automatically gets created, do it actually delegates to the people also, like who can solve that?
Well, I'm a team of one right now, so like it just assigns it to me. But if you gave, I mean, it can do anything, right? I mean, if you gave it some, some information, you just gave it enough context to say like, well, if it's in this area of the code or back end, whatever, or you could probably create teams within GitHub that are appropriately named, like back-end engineers, and then it would just assign it to the team.
Linear was an Australian app that I was telling you about.
Oh, okay.
That's
I've heard good things about Linear.
I like Linear.
Yeah.
I do like Linear. Coming from Jura and like Atlassian background, like.
Well, that stuff feels so old.
Like,
GitHub Issues is lightweight, and it's already in the tool set that I already run, so I feel like it's pretty cool for what I'm doing. But what I think about what Linear is doing right is
How many people on this live stream?
quite a bit.
Is there a lot?
Well, 7, because me and Kody.
Well, I'm just wondering because like we ended at like 100 levels on it last week.
Right. I wonder if they could find it.
Well, I just went. That's why I just went downstairs. But there's no one walking around the lobby or anything like that.
Okay.
I do know it's I/O. I don't think that would conflict with us.
Yeah. Yeah. We want to get started?
I think we should give it like
Okay. Start at
10,
7.
15 minutes.
So what Linear I think is doing right is if you do everything CLI first, then agents can talk to it.
Yeah.
So I think like Sentry has been like adding functionality to their MCP server so that it not only Sentry's been doing a lot, man. If y'all use Sentry?
I only use Sentry for like what's it called, my hobby project.
Yeah. So I started out just with Sentry issues, but then I added, I did full-on Sentry logging, front end and back end. And then they just released a feature like in the last few months where they will initiate a trace ID on the front end and ship it across the wire to the back end. So now I can correlate an entire trace front end to back end with logging. And then they'll put all that context in the issue. So if you do have an issue, it'll say, well, here's the log snippet right around, and then if you drill in, it'll show you the entire trace of what happened. I mean, it's nice. And then they're exposing that to the MCP, so then I can tell Claude, like, I want you to look at, if you've got an issue that's pretty common, look at 10 of the most recent events, and then look at all their logs and try to correlate, like, what might be a root cause out of that. Like, just compile all that information into the GitHub issue.
Okay.
Is all that integration easier to set up, or you just behind the scenes stuff to get that working?
That was easy. So that they have a Sentry MCP server that is easy to install, and then it just, like, I didn't have to teach Claude about it. I was just like, Claude, you've got Sentry, go search it for, like, literally I just told it, go find the highest priority issues. I did tell it, expand your search, because sometimes you'll see an issue that's like, it's the same problem, but it's like 10 different issues, because it depends on like where it hits in the code base or something. I did say, like, try to find correlations with other issues and then group them. So if you open an issue with one, find the other 9 that are related. So I had it expand its list, but it knew what to do, like, because it looks at the MCP documentation and knows how to search its logs and do all that stuff. It'll even assign the bug to me, so I know that, like, this one's in progress.
I gotta actually dive into MCP servers at some point. I hear the name, but I never actually.
Well, just think of it like but you don't really need to know how it works. You just need to know
What it is.
You just need to know who to hook it up. So just go search Sentry MCP, and then there's a one-page document that's like, run these 2 lines of code inside Claude Code, and you're done. And then you have to authenticate with OAuth, and you're hooked up. And then
I like that.
the thing about MCP is, in the commands, it's got enough like documentation about what the command does and what it's for that Claude can read it. So Claude knows, like, oh, well, I can search the logs and I can search issues because the MCP exposes all that. So Claude knows how to use it. You don't even know how to use it. You need to know how to use it.
Abstraction.
Yeah.
Yeah, that's crazy. Yeah, we're using MCP servers at Very Good Ventures for the Scooters project.
Yeah. What are you doing with them?
So basically,
like, you created your own for your project?
No, so basically we just like have a Figma design, and then link that up to tickets, and then have that combined together to make a Flutter instance.
Straight off the Figma.
Yeah.
Interesting. So on one of my projects, that List Maker one, my business partner is a designer, which is why that app is done well, because it's got like a real designer behind it.
Yeah.
And we've been talking about this like back and forth, because he designed in Keynote because he was an Apple designer. And I was like, man, Claude cannot read these keynotes. And so now anytime I'm doing UI work on your project, it's really slow. Like, basically I have to go back and hand code the UI off of your stuff. He's like, well, that sucks. And so we've been trying to like iterate on our process. That dude, he got turned on to Claude Code when it went into not the terminal, but like in the app.
Oh, or like in the
Because
PS.
he won't go into the terminal. He's not an engineer, right?
Oh, okay.
And so he was just like, it's intimidating to him. He's just, I'm like, this is too engineering for me.
Yeah.
But when the app came out, he's been building a prototype version of our app, which just like, there's no persistence, there's no auth, it's just the UI.
Yeah.
Right? And then, so then I hooked him up with a GitHub repo for the prototype app.
Yeah.
And I'm like, all right, just tell Claude, because he doesn't want to learn Git either. I'm like, just tell Claude to push your changes to this Git branch when you're ready.
Yeah.
And so that's our new model that we're trying. He's literally giving me a prototype of the app that works.
Oh.
Right? It looks the right way. It works. It functions correctly. The animation's correct, because he's sits there and iterates on it with Claude. And then I get it, and I'm like, okay, I've got to implement this drag and drop stuff that he's doing. But I've got a prototype. I need you to go read his code, and then you've got to adapt it to our production app and bring his changes over. Still doesn't happen perfect, but it's better. It's better, yeah, because it's working code.
Fired up.
Yeah.
You do a very interactive presentation. This is really good. I think what are the things we need to go through? I think everybody here is registered on GDG or the Flutter Medium, right? If you're not, please do get registered. So we do post all the events there. And then I think we went through parking. If anybody needs a parking pass, please grab one. What else? Is there anything else we need to go through? That's pretty much it, right?
Maybe we introduce ourselves.
Yeah. So I'm one of the co-organizers of GDG, along with Chad and then Mike in the back. GDG is like the big umbrella, and then the Flutter Medium kind of sits under that. So we do events all involving like Google technology, so GCP, Kotlin, all of that stuff. So if you are on the GDG platform, you will get access, and you'll see all of those events as we post them. And then obviously Kody is our guest of honor today. Kody's the senior director at Foresight Sports. And I've seen Kody's work firsthand, and what they do at Foresight with the Flutter framework is just really interesting and pioneering. It's very early adopters of 3D animation, all that stuff, and him and his team are just constantly pushing the boundaries of what's possible. So we're gonna get a little insight today as to how they do that. So I'll pass it to you, Kody.
Yeah. You guys think I need a mic, or are we good? I can hold one if we need one. Everyone hear me good?
Yeah, I hear you.
For the live stream, you might want to have. We have about 50 people. I have a live stream.
I think.
Oh, okay, good.
Yeah, he's mic'd up.
I was just wondering about like, if you guys think I need this.
Oh,
Probably not. No. Cool. All right. I want to start with a question. When does your app start? Most people would probably say when the home screen loads. Maybe when authorization completes. Maybe it's when the first time the user taps something and something happens. For us, it starts the moment the splash screen appears. Before a single tap, before the user has done anything at all, it's the moment their brain starts forming an opinion about the quality of what they're using, about whether this product is going to earn that trust. For us, you're either shaping that moment or you're ignoring it. And my clicker is not working. All right, well, let me see. There we go. Since the moment you've walked in, you've been watching our splash screens. I'm Kody Peterson, Senior Director of Software Engineering at Foresight Sports. Those on the table are launch monitors. We were talking about them a little bit earlier. They measure exactly what happens when a golf ball is struck. Speed, spin, trajectory, where the club made contact. Driving ranges, indoor simulators, people's garages. We build the software that makes all of that data meaningful. That question I just posed, when does your app start, is really a smaller question of what we live with every day at Foresight. What does a world-class experience actually demand from engineering? Oh, this presentation, it's also built in Flutter, but we'll come back to that. Pick up the hardware on the table. It doesn't do anything until you use it. Coffee maker on your computer, or on your counter, the headphones on your desk, they're inert. They're not making an impression until you reach for them. An app isn't like that. The moment someone opens it, it's already performing. Every screen they land on, every transition, every moment spent waiting for something to load, all of it's communicating something about the quality of what they're holding. There are no neutral moments. It's all signal. That animation you were watching, it's not a spinner. It's a constellation of data points, representations of all screen appears, before you've done anything, before you've seen a single number, it's already telling you something. This product is precise, this product is considered, the product cares about what it's doing. You can't unmake that first impression, so you might as well make it count. Everywhere engineer in this room knows what works mean. Tests pass, data loads, no crashes, ship. Feels right is harder to define. But users detect the absence of it immediately. They can't tell you what's wrong, they just know something is. The app feels off, even if it's technically correct. The gap between those two things is where most apps live. Not because engineers don't care, they do, but because closing that gap requires a deliberate decision that it's worth paying. Most teams haven't made that decision explicitly. This talk is about what happens when you do. Now, we build software for hardware that people trust to make real decisions. Not the kind of trust where you open an app and you open it again tomorrow. The kind where someone looks at a number and says, I'm going to change my golf equipment based upon that. That raises the bar. These devices measure the fraction of a second when club meets ball. How fast the ball leaves the club, what direction it's spinning, what angle it launched at, how far it carried, how far it went offline. And on our iron units, exactly where on the flat face of the club the ball impacted. What angle the club was facing, whether the face was pointing towards the target or rotated away. Every one of those measurements is a variable that determines where the ball goes and why. When people hear precision golf hardware, they picture a tour pro or professional club hitter. And sure, that's part of the picture. Tour professionals do use these devices. Hitters use them when they're helping a golfer find the right equipment. Teaching pros use them to diagnose swings. That's not most of our users. Most of our users are everyday golfers. The guy with a simulator in his basement, the player practicing in a garage, hitting into a net, the weekend golfer who goes to the range a couple times a month to see whether the changes they've been making are working or not. The range of people using this hardware is enormous. The stakes look very different at every level, but the expectation is identical. When a number appears on the screen, it's right. The trust creates a very specific burden for us. The hardware earns its reputation through accuracy. Users internalize that, then they open the app. If the number on the screen doesn't match what the device just showed, even a rounding difference, the first thought is, which one is right? And we're introduced doubt into a relationship built on that trust. And that's a hard thing to recover from. But it goes deeper than data matching. If an animation, a ball flight feels sluggish, it subconsciously calls the underlying numbers into question. If UI feels sloppy, users don't fully trust what they're reading. It's not rational, but it's real. Software doesn't just display data, it inherits the credibility of the hardware it sits alongside. Software either reinforces that trust or erodes it. There's no neutral option for us. Most engineering teams believe that the benchmark they're working is against the competition. Are we better than the other apps in our category? That's reasonable for most products. It's not ours. Our benchmark is, does this feel as precise as the hardware it represents? That's a fundamentally different question, and it cascades into every decision downstream from it. It's why we don't use material or Cupertino defaults. These components carry the visual language of Android and iOS, and that's not Foresight's language. It's why animations are decoration in our world. They're a form of communication. Sluggish animation communicates imprecision. A perfectly timed one communicates the opposite. It's why loading states get engineered, not afterthought. If our hardware is trusted for accuracy, our software cannot feel approximate. That's the bar, and meeting it doesn't just require good engineering. It requires a specific kind of engineering culture. A team that has made a decision around what the standard is, and that starts with how design and engineering talk to each other. Most engineers are quietly in the business of negotiating design down. You've been in those conversations, I've been in those conversations. Can we simplify that animation? Does the spacing really have to be exactly that for 3 days from sprint end? That negotiation isn't malicious. It's the natural outcome of engineers being measured on what ships, not how it feels when it does. We made a deliberate choice to flip that. When design shows us something, the question is never, can Flutter do this? It's always, how do we get Flutter to do that? They sound similar and they're not. The first one is looking for an exit. The second one assumes yes and starts figuring out the path. That's a cultural decision, and it has real technical consequences, because the answer to how do we do this is almost always we build something that doesn't exist yet. Which brings me back to this presentation being built in Flutter. We could have used keynotes. It would have taken an afternoon, but instead we built custom presentation software that embeds the live app directly into the slides. What you're looking at isn't a recording, it's not a screenshot, the app is running. I can interact with it. There's two reasons. First, practical. I don't have to switch windows to show you the app. Even more challenging than the laptops over there. Secondly, if I'm going to stand up here and talk about how much experience matters, how every detail should be intentional, then this presentation had better prove it. The transitions, the design language, the care and how things are shown, they should be consistent with everything I'm about to describe. That's not going above and beyond. That's the standard. One day, the design team pulled us into a review. They've been working on a concept called club view, a way for golfers to see exactly where the ball contacted the club face. I walked in expecting a static image of a club, a dot on the club face, buildable, straightforward, knock it out in a sprint. What they put on the screen was a fully animated 3D club head, rotating between 3 camera perspectives, smooth cinematic transitions, real materials, real lighting, running on a phone. And I just sat there. My honest reaction was split. That's incredible, and I have no idea how we're going to build that in Flutter. And then the next thought, all right, let's figure it out. The point isn't the solution, the point is the posture. We didn't say that's too complex. We didn't say Flutter doesn't do 3D. We said we don't know the path yet, and actually that's a great problem to have. Our job as engineers isn't to constrain design, it's to make it possible. That's the culture, and we're about to walk you through is what came from it. 3 pieces of work, 3 different problems, and honestly, 3 different kinds of problems. So, let's start at the beginning. That moment I told you about, the design team in a review, me sitting there with no idea how we're going to do it, we figured it out. It cost us 3 systems we've never built before. 3 systems nobody had ever shipped together in a production Flutter app. Look at what club view actually has to do. Real geometry, the club head has complex curved surfaces. Real materials, physically based rendering, accurate metal, accurate reflections, free cinematic cameras, smooth, choreographed. And Flutter UI data overlays sitting above the 3D scene, repositioning correctly as the camera moves. Can't fake any of this. The experience demands reality. So we looked at our options. Flutter native 3D, not mature enough yet. It was like literally just announced when we were working on this. No camera control, no scene management, no PBR. Unity, seemed obvious. We have a Unity team. We create golf simulation software using Unity. We actually prototyped it. Made sense. And the problem stacked up pretty quickly. Version lock-in, an unsupported communication layer, and the killer. 200 megabytes of RAM, even when Unity's not rendering anything. Not viable across all the range of our devices that the users use. And then, one weekend, I was watching a conference talk by the SpaceX Starlink team. The talk was about how they built an AR feature in their app, the one that lets you point at the sky and see the satellites overhead. Their app is built in React Native, and React Native doesn't natively support what AR needs. So they embedded a WebGL context inside of WebView, driven it with JavaScript and pass messages back and forth between the 2 runtimes to coordinate it. A completely different feature from anything we were building, but the wall they hit was the same all week in. Different frameworks, different features, same constraints. I watched that and thought, features in ours, but the pattern is, I wonder if we can do that Flutter. That question became the entire architecture. 3 layers stacked vertically. On top, Flutter with overlays, buttons, states, everything the user interacts with. In the middle, a web view hosting Babylon.js, a mature, production-grade WebGL engine. Babylon's background is transparent. It renders the 3D model and nothing else. On the bottom, Flutter again. Backgrounds, gradients, framing. The user sees one continuous screen. Under the hood, completely independent runtimes coordinating in real time. That coordination happens through a custom Dart to JavaScript bridge. Web views give you basic message passing out of the box. That wasn't enough. We needed structure, versioning, typed messages. Commands flowing one way, switch this camera, load this model, begin the transition. And everything flows the other way. Scene ready, animation started, midpoint reached, animation complete. Acknowledgement, strict error reporting, a proper protocol. And we're planning to open source it. If you're building anything that puts a web view next to your app and needs coordinated behavior across the 2 runtimes, which I'm sure everyone does, that's this piece. We built Code View, we tested it, the 3D was working, the bridge was working, we were incredibly proud of it. We submitted the App Store. Your app is too big. We had never, at any point, considered that there might be a binary size limit we'd run into. And the 3D models were only part of the story. Our app already shipped with heavy media, high quality marketing images, PNG sequences, full resolution video, and the dense 3D geometry and layered PBR textures on top of that. And we've been treating every one of them like regular assets in the pub store. So we sat down to figure out how to deliver them outside Flutter. On iOS, that's on-demand resources. On Android, similar mechanisms. Both work, assets get delivered at install time, the binary stays small, the app stores are happy. But once these models live outside the bundle, they land in variable locations. Path shifts between builds. Web views have significant restrictions around file access. Babylon assumes HTTP URLs. None of these things are compatible with each other. So we embedded a lightweight HTTP server directly into the app. What else are you going to do? Everything gets served from localhost. The server is the abstraction. It doesn't matter whether an asset came from ODR, if it came from the bundle, or it came from cache. Babylon always gets a stable URL, has no idea where the file actually lives. That single finding is what led us onto a path with a fully functional HTTP server running on a mobile application with 3D assets in a WebGL context running over loopback. It's not a sentence I ever expected to say about that. But it's the right architecture for the problem we ended up actually having, not the one we set out to solve. And honestly, I think that's most of what doing something that's never been done before is. The problems you ship aren't the ones you anticipated. They're the ones the constraints surface for you. 3 layers, a bridge, an HTTP server, that's the infrastructure. The hard part was none of that. The hard part is timing. When a user taps switch beside you, Flutter receives a tap, Flutter animates the overlays out, sends the camera command, Babylon starts moving, Babylon signals back, animation started, and midpoint, then animation complete. Flutter animate overlays back in, positioned to new camera angle. 7 steps. Any one of them fires at the wrong time, even by a fraction of a second, the whole thing falls apart. Overlays back too early, the camera's still moving, and they fly across the screen. Too late. The user already sees the scene. Camera settles before the overlays are ready. The scene looks empty. I remember the first time we ran it end-to-end, and it almost worked. The camera moved, overlays animated, almost in sync. The overlays were coming in about a beat too early. For 1 microsecond, there before the camera was done moving. Just enough off that you knew something was wrong. Not enough to tell you what. We watched that loop for hours. Rerunning, tweaking the timing, rerunning, tweaking the timing. Frame accurate. That's the bar. And it's entirely dependent on Babylon telling Flutter exactly when each phase begins and ends, which is why those animation lifecycle events are first-class messages in the bridge protocol, not afterthoughts architecture. I was on the BGB podcast a while back, and I said something I keep coming back. UI is just a facade. We're having you believe what we want you to believe. You wouldn't know there are two systems, and that, to me, that's a huge success. I think about that line a lot because that's the whole job right there. Users don't see two systems. They see one experience or they see a bug. There's no in between. So that's how we figured out the problem earlier. The design team in the review, me sitting there with no idea how, three systems we've never built before, frame accurate timing across 2 runtimes. A real 3D engine, quote unquote native to Flutter. And then the next brief came across our desks. Show a golfer their shot flying down a driving range. The obvious answer was here's what we just built. We made the deliberate decision not to. Range view needed users to feel like they were standing at the end of a driving range, watching their ball fly 300 yards, arc up, and land exactly where it did in real life, on a phone screen. The natural tool for that is the 3D engine. We had one. We just walked through how we built it. Drop a ground plane in, animate a trajectory along a curve, point a camera at it, solve the problem. But the more we looked at what range view actually needed, the less the right tool felt like a 3D engine. A ball in flight is a point moving along a curve. Nothing about that requires geometry. The camera never moves. One fixed perspective, like standing behind a tee. And the whole thing had to render fast, alongside live shot data on whatever device our users happen to have. When your camera doesn't move and you don't have 3D models, you don't need a 3D engine. You need a convincing illusion of depth. That changed the question we were asking from which 3D engine do we use to what actually creates the feeling of depth. The answer started with a tool that gives you absolutely nothing for free. Flutter's Custom Painter. Anyone use Flutter's Custom Painter? Direct raw canvas access, no libraries, complete control over every pixel, and no perspective, no depth buffer, no shadow casting. Every cue of depth has to be measured through math. The math we used is called a homography transformation. The same technique your phone uses to straighten a document when you take a photo of it. You define 4 corner points, an imaginary rectangle, and specify where they should appear when perspective applied. The matrix handles the rest. Lines that were parallel become convergent, meeting at a vanishing point. Grid lines that were evenly spaced compress as they reach the horizon. Every shot coordinate, every grid line, every trajectory point passes through that transformation. That compression is what makes a flat canvas feel like a 400-yard deep range. Here's the thing about the background. It does about 90% of the work. With a static camera, there's no movement to establish depth, no parallax, no dolly. The background carries the illusion. When the vanishing point sits at exactly the right height and the texture compresses correctly towards the horizon, something clicks. The brain stops analyzing and it just believes. The math is the foundation. The experience came from iteration. A lot of iteration. We built in-app debug panel with real live sliders for every parameter. Grid width at the front, compression at the horizon, vanishing point height, every one of them. And every number was derived the same way. Fire a shot, watch the tracer, ask, does that feel like a Those numbers are not derived from a formula. They're calibrated from human perception. And my personal favorite, the peak height formula. A short 50-yard wedge gets a scale factor of 38, but a 300-yard drive gets 8. Everything between follows a linear decay. The physics don't require this. A 300-yard shot and a 50-yard shot are proportionally similar. If you plotted them accurately at the same scale, the wedge 50-yard shot would look like a tiny arc hugging the ground. But on a screen, that wedge shot barely gets off the ground and it doesn't feel believable. You need to see the arc. You need to read it as a shot, not a ground ball. So we gave it more visual height than reality actually would. We optimized for belief, not for accuracy. They aren't the same thing. This is what it produces. Users don't see the math, they don't see the sliders, they see a shot. Background does a lot of work. One idea drove every decision in this feature. Users don't want mathematical accuracy. They want to believe. A perfectly correct perspective projection can look technically right and feel completely sterile. A slightly adjusted arc that lands exactly where your eye expects it to, that feels real. Even if a physicist would tell you it's off by a few pixels. We asked one question for every technical decision in this feature. Will the users believe this? Not is this correct? Not does it pass the test? Will they believe it? If it's technically correct, but it doesn't feel right, it's wrong. Range view worked because we knew what not to build. This one is different. This is the one where we realized the problem wasn't the problem we thought it was. A launch monitor that measures ball speed within a fraction of a percent is an extraordinarily precise instrument. But precision doesn't automatically produce improvement. Trust me, I've been trying. We had all this accurate data, and we realized we were actually facing two different engineering problems. The first was measuring precisely. The second was making that precision actually change how someone practices. And I want to be honest with you, the second one is much harder. So we had to reframe what we were even doing. Visualization is an output layer. It takes data, it presents it, it answers one question: what happened? Training is a system. It has to answer a completely different set of questions. What defines success for a shot? How do you reference the behavior you want without breaking the rhythm of practice? How do you make sure a session you do today is as meaningful in 3 months? Those questions aren't UI questions, they're product logic questions, state modeling questions, behavioral design questions, and they have to be answered in code. That reframing pushed us towards strict separation. Scoring logic doesn't touch the UI. Rendering code doesn't know what a hit is. The boundary made iteration fast. And product was iterating on drill formats every week. And it pushed us towards something more specific. The entire training feature around a single sealed class with a concrete subtype for every drill type. Ladder drill, target practice, off the tee. Each subtype carries its own configuration. Each one defines its own scoring strategy through extension methods on a shared memory. So when product decided in week 3 that they wanted a 4th drill type, it was a compiler-driven process. Find the new template subtype, define its session subtype, implement scoring exception. Compiler tells you everywhere that needs updating. In the domain where the rules were changing weekly, and we were trying to define how training works, that guardrail paid for itself in the first week. Scoring logic is where this got interesting. We tested a symmetric linear drop first. It felt completely flat. Users couldn't distinguish a great shot from a mediocre one. The emotional difference from 100 to 80 points didn't even seem to register. So we changed it. We used a piecewise linear curve. Generous for good shots, punitive only for clear misses. A perfect shot scores 100. At the break point, half the target radius from the pin, you Beyond that, the score decays deeply towards zero at the edge. The feeling of making a great shot versus a mediocre one became legible. The math is simple, but the foundation and motivation for the math is entirely about how humans respond to feedback. That's not a UI decision, it's an engineering decision, grounded in psychology. Pacing work the same way. 2.5 seconds. That's how long the transition between drill targets takes. Camera eases back, current target fades, the next target appears. We tried shortening it, got it down to about 1.5 seconds. It felt awful in testing. Too rushed, users weren't oriented before the next drill started. The 2.5 seconds isn't waste. It's the cognitive reset window. The moment someone mentally closes out the previous shot and prepares for the next. Same thing elsewhere. Shot tracer animation, run for the ball's actual hang time. Because mirroring physical reality grounds the visual in something the user already has intuition for. Audio cues fire at the frame the tracer animation completes, not when the hit or miss is actually calculated internally. Those are different moments. User perception is tied to visual one. Treating pacing as a real engineering constraint, not as polish, was one of the most important shifts we made on this feature. Okay, one more thing. We treated camera framing as a rendering concern. That was the mistake. For weeks, we were debugging the wrong thing. The camera felt sluggish, so we had it easy. The camera felt jumpy, so we tweaked durations, adjusting curves, rerunning, adjusting curves, rerunning. Nothing felt right. Until someone on the team, and I wish I could tell you it was me, finally said it. Wait, are we even solving the right problem? This isn't a rendering question. This is a session state question. And the architecture rearranged itself in our heads. When a shot animates in our training feature, the camera doesn't just follow the ball. It pre-calculates a bunch of keyframes, zoom level, heights, positions, one per segment of the path. As the ball flies, the camera interpolates between those keyframes. It tracks smoothly from a wide T view to a tight target view as the ball lands. Holds for 3 seconds, then eases back to lock target position over 1 more second. That hold and reset window, 3 seconds, then 1, isn't a render decision. It's the moment the user processes what just happened. It's a session state question dressed up as a camera animation. The camera doesn't live in the rendering layer anymore. It lives right next to the session state. It knows about the target geometry, shot context, when the user is in the drill, not just world coordinates. Camera framing isn't presentation. It's product logic that happens to render. 3 different problems, 3 completely different technical solutions. But there's one thing about every single one of them that had in common. And that thing is something nobody puts on a roadmap. In each of those features, there was a layer of work that didn't appear in any ticket. Features already functioned, test passed, data rendered, nothing crashed. But there was a layer on top of that, the layer that made it feel right. And in every case, the layer was deeply technical. Polish gets treated as decoration, the thing you do if there's time left, as the design team's problem, as the thing that falls out of scope when the sprint runs long. And everyone implicitly agrees it was never really mandatory. But look at what we've actually been describing. Club view, animation lifecycle events as first-class messages in a bridge protocol. Because getting 2 runtimes to feel like 1 required timing as architecture. Range view, a custom equation that adjusts the visual arc for every shot, because a mathematically accurate arc doesn't feel believable to the human eye. Training, the 2.5 second cognitive processing and reset window, audio firing at the visual moment, not the data moment. Timing systems calibrated to cognitive processing. Animation pipelines coordinated across 2 runtimes. Scoring curves grounded in psychology. That's not decoration, that's engineering. The most honest thing I can say about building ambitious apps. Every framework takes you Flutter, Flame, Babylon JS. They're all roughly 70% of what you do. They're excellent tools. That last 30% is always bespoke. Custom zoom, interpolation, blend, and support. A bridge protocol WebView primitives couldn't handle. A scoring curve of a library no one knows your users need. The polish layer, the thing that separates works from it feels right. That's exactly where the framework stopped helping and the engineering begins. This isn't a criticism of frameworks. It's the nature of building something different. If your app wants to feel like something nobody else has built, you have to build the parts that nobody has built. Unrelated point about perceived performance. Users don't experience milliseconds. They experience the feeling of responsiveness. An animation that takes 300 milliseconds but feels instantaneous is better than an animation that runs 100 milliseconds and feels laggy. The raw time is irrelevant. The perception is the metric. Once you start looking at your app through that lens, you can't unsee what has to change. 3 things to take back with you. First, Flutter gives you control. Use it. Material and Cupertino are excellent starting points, but they carry opinions that may not match your product. Custom Painter alone unlocks the entire range view. The engineers who build world-class apps are the ones that know when to leave the defaults behind. Second, think in systems, not screens. Most apps are built screen by screen, and most experiences fall apart in the transitions, the moments between screens that teams never fully design. Before you write the first widget of a new feature, ask what happens before it and after it. The scenes are as much as part of the experience as the screens themselves, sometimes even more. Third, optimize for perception, not just correctness. Technically correct and perception correct are not the same thing. A wet shot that has more visual art because it gives it audio firing at the visual moment, not the data moment. Users don't experience your code. They experience the feeling your code produces. When something is correct but feels wrong, don't rationalize it away. Fix it. The feeling is the signal. Here's what I want you to do next. Go back to your product, find 30%. The timing that needs calibration, the transition that needs choreography, the state machine that needs orchestration, the feedback that needs tuning. The moment where it works and it feels right are currently 2 different things. That's where your users are forming their opinion. That's where the experience actually lives. That's where your best work is waiting. We started with a loading screen. We ended up with homography matrices, GL context instead of web views, scoring curves tied to human motivation, timing sequences calibrated to cognitive processing windows, very different technical problems. But every one of them was driven by the same question. Will the user trust this? Experience isn't something you add to an app. It is the app. Every technical decision either serves it or it doesn't. There is no neutral option. When every detail is intentional, users don't notice the engineering. They just trust the experience. Thank you all. Go build world-class experiences.
All right. Do you want to open it up for QA?
Let's do it. Questions.
And then so I just want to say, as you get questions, repeat them.
Okay, I will do that. And if also if it's app related, we can show the app too. But I can't easily control it, so don't ask app related questions. We'll figure it out. Do you have a question?
How did you do the actual testing? Was it in-house as you were iterating, or did you bring in external people, or you just have dedicated users with a meta install?
Yeah, so the question is, how did you do the actual testing? Did we do it in-house, or did we have external users, etc.? Yeah, so I work with a lot of golfers because they gravitate towards building golf things. not golfing, or they were pros, or pro amateurs or whatever, and then they become older. So we test a lot internally. Those hundreds of shots that we talked about earlier, that's done internally in our hitting base. But we also go externally for sure. I go on tour all the time to check in with the pros, have them try out our new stuff, understand how they're feeling about it. We talk to our users, understand what they're, and get their feedback. When we're trying to figure things out, we'll reach out to that audience. We have a lot of golf experts on staff as well, so we get a lot of our intuition there and understanding. And then we just have really great people who are grounded in the same culture and the same philosophy that I talked about tonight, that want to make sure that the experience is unique. And so that just pushes us to continue to find those tiny moments, that sort of stuff, and literally sitting there for hours. But yeah, it's a lot of internal testing, a good amount of external testing as well, but a lot of internal.
I guess my question goes to if before it was on the app store markets,
Yeah.
whatever you want to consider, were you giving somebody a device that had it, like a beta version of APK installed, or?
Yeah, so the question was, before we push it out in the App Store, how do they test it? Yeah, so we've got development and staging environments. And so for our development environment, we generally use Firebase app distribution. So pretty easy there. We use that for iOS and for Android. And then in our staging environment, we go to test flight for iOS, and then under a different name, and then we go to the closed user testing on the Play Store side of things. What that allows us to do is find out when the app is too big, so that we can do that kind of before the production side of things, and before we're kind of too far onto the other side. So we can get a lot of that understanding ahead of time. But yeah, that's our kind of cycle that we run through. And so we can give access to users through Firebase really easily through that app testing. You just get a Google email address from them, and then or a Google account address, and then send them one. We find that that tends to be a lot easier than the test flight and the closed testing or whatever it is. It's just a lot easier to navigate, so we generally do that. Yeah, but sometimes we're just giving an iPad as well. So like when I'm out there on tour, for example, we've got a bunch of iPads that we're just kind of that's not the time to install apps, right?
Yeah.
So yeah, we'll kind of do a mix of both. Yes.
First of all, very good presentation. I was curious. In part of the presentation, you showed that formula for, I think it was determining the height of the ball or something like
Yeah,
that.
peak height formula.
And I assume that was Flutter code.
Yes.
Correct.
Yeah.
Was there any other moments like that that you can recall that actually like made something very simplistic because you're using Flutter specifically for the project?
Yeah. Okay. So the question is.
It might have been kind of long-winded.
Yeah, so the question is, it's like, I showed the p-type formula, which was pretty easy. I will say that's an abstraction of it. There's a bit more to it. Are there other moments in Flutter where we were able to write kind of simple things because we're utilizing Flutter, because we're utilizing Dart to do that, versus we had to do it elsewhere? Yeah, for sure. I mean, I think one of the best things about Flutter is the package ecosystem. So we can lean easily on other libraries and not rewrite those. Swift has that for CocoaPods, and Kotlin's got it as well, for like a package manager. So generally, it's probably when we're interfacing in that way. Our biggest win is Pigeon. If you have not heard of Pigeon, Pigeon is a way to automatically write a bridge between the native side, Swift or Kotlin, and the Dart side. And we have a lot of that happening because our devices are talking to the iPads, right? We're doing that through Bluetooth communication, and we have a whole other SDK team that builds the native SDK in order to talk to those devices through Bluetooth, as well as our other C++ and various other methods as well. And so instead of us having to write that through platform channels, right, and custom hand write that through platform channels, at least the communication layer, we can utilize Pigeon to help us with that. So that's, I think, where the Dart ecosystem helps out a ton. I also don't have to write twice, right? That's the whole value prop of Flutter. It helps us immensely. I also don't know how some of what I showed you today would be able to do if we had to do it in Swift and in Kotlin. I mean, it's hard enough in one ecosystem to do that in two. Yeah. So the whole app and the SDK layer for sure. Yeah. But Pigeon, great library. Any other questions? Yeah.
Yeah. So, did you, since we've talked a lot about Flutter, did you run into any like dead ends or brick walls with Flutter that were? I mean, I know you had challenges, but were there just paths that you were just like you just can't go down this?
Yeah. So the question is, with Flutter, have we ran into any dead ends or just paths where we just kind of couldn't make it? No, not yet. We carved out our own path in most cases. The club view being one of them. I'm sure nobody here has probably heard of 3D and Flutter outside of Toyota announcing that a month or so back. It's stealing my thunder, but that's okay. I'm super happy that that's great. But yeah, no, I mean, we're just continuing to dig and continuing to find a solution when we get crazy things thrown at us. We're currently working on some text-to-speech stuff in ear, we call it, in terms of feedback and stuff like that. And that's provided us some level of challenge, but we found that as well. And it's just being able to have the opportunity to take the time and the culture to take the time to do that versus the culture of like just need to ship these to this sprint and this is the thing. And we all have deadlines. We still have deadlines on our side, but we just ensure that we kind of built it in. And we have amazing engineers who are built this culture and they work around that. And I can't say enough about the team. They're really great in order to be able to handle that. But yeah, we haven't found a dead end yet. We're looking for it. Yeah.
Yeah, again, amazing presentation. The first problem that you ran into and that you built the solution for, solution space for the 3D rendering, like you said it was open source as well too. Where can we find that solution?
Yeah, so we haven't open sourced it just yet. The question was regarding the 3D stuff and that we're going to open source that solution. We haven't open sourced it yet. We're packaging it and kind of getting it ready for open source. Kind of when you build stuff like this, it's a lot of getting it to work for your use case and then starting to think about, okay, well, how can we make this work for others because we want to make this beneficial to everyone else. So we're working through that and we hope to have that somewhere around July right now. Unfortunately, moving things to open source kind of takes a little backseat when we've got problems to solve like this. But yeah, we're definitely going to start getting back in that way to the community through packages. So we'll have that bridge layer. We'll have kind of the 3D the way we did that and some of the components that we leaned on for that as well opened up there. Yeah.
Okay.
How big is the Foresight dev team? How are you organized?
Yeah, so how big is the Foresight dev team? So we have 4 engineers full-time on the team, and we generally kind of try to break things up by feature. So we're very feature-driven. Our app structure is very feature-driven, and so it allows us to kind of do it in that way. And they're all kind of working on various different things at the same time, but still, completely working together with each other. We do contractors for sure at some times if we're scaling or coming down. Right now we're in kind of a steady state as we're kind of ramping up for some other operations as we prepare for our golf simulation software that we announced about to come out in July, and then kind of gonna probably ramp up.
And that's 4 Flutter engineers.
4 Flutter.
So like you're not talking about the back end team.
Yeah, no, yeah, we've got a back end team as well. We've got a Unity team. I keep kind of referencing that. We also have golf simulation software. So you hit into a projection screen and the simulation happens there in full 3D. And so we've got a huge team for that as we're kind of building out the next generation of that software. And then of course we've got all the other teams that you would expect a business to have.
You said that there's like an SDK team, so they're writing Dart.
Yeah, so the SDK team doesn't write Dart. We handle all the Dart side of things. The SDK team writes in. Right now they're kind of just like Swift and Kotlin and whatnot. We are experimenting a lot with like a bridge solution there as well, so we can write once in one language, think like Rust or C or something like that, and then it translates over to the other ones. So then our SDK team can write once and build everywhere too. And so we're working, for that. But yeah, we've got an SDK team that handles SDK integrations for things not just for mobile but like our desktop as well. And then we've got a whole hardware team. Of course, it takes a lot of time and energy to build these amazing devices and the precision around that. Yeah, great team.
Very cool.
I was curious, how big was the app when you were trying to push it up and it was too big? I thought the limit was like 4 gigs.
Yeah.
Just the second part of that question, you said you pulled the assets out, but you didn't necessarily manipulate them, you just had them pulled down after the base.
Yeah, so the question was when we ran into that app is too big problem, how big was the app? You mentioned the 4 gig number. smaller for the AAR. That's where the problem ran into play. We were at the time before we introduced Club View and when we launched for the very first time, we didn't realize this. We were at 198 megs. We were just about there, but we didn't know because nothing ever surfaces that and tells you. And we have a ton of PNG sequences. Our design team, as you can tell, they're very meticulous about how things are shown and in the ways that they're shown. We've got this glow, we've got a design language, and so that requires a lot of assets to kind of make the illusion possible. And so we added the Club View and whatnot, and boom, we were over on the Android side. iOS is fine, we could have gone, but like that's not how we solve things, right? And so we looked into ODR on demand resources. And so what ODR does is it takes, you create bundles of assets, and those bundles also have a max size as well on their own, and there's a certain number that you can have. And when your app gets downloaded, you can do one of two things. You can either have those load in later, so you can actually reference and say, now load these assets in. You don't need them for startup or anything like that. Or you can tell it it's requiring for the app to even start, so it happens during that initial install phase. We chose to do that because our whole concept is offline first. The app needs to work in driving ranges and stuff like that, which generally don't have great connectivity, or you're using an iPad that is Wi-Fi only, but there's no Wi-Fi, blah, blah, blah. So we have to be really kind of focused on offline firstness. And so that's how that works. It's like you get these extra bundles, they have a limit. If you reach that limit, you move into other bundles. I think at this point we've got like 4 bundles spread across the link in order to make this work. Yeah.
Thank you. Very
Yep. Yes.
Okay, so for 3D modeling in Flutter, do you use only Flutter or some CAD modeling tools and you integrate them?
Yeah, so the question is, for the 3D in Flutter, do we only use Flutter or do we have CAD tools? Yeah, so the club that you saw there, we've got every club modeled out. There's a bunch of them in Go. And so our design team renders those out in Blender. Those create what's called GLB files. And the GLB file has everything in it, the geometry, the texture, the lighting, and that sort of stuff, or how the lighting interacts with it. Those GLB files is what Babylon loads into the scene. And then we manipulate those models, and we move them, we do all the animations that you saw there. So some of it's camera movement, some of it's actually the model being moved back and forth. And so that's kind of the 3D space. So when it comes to 3D, and what you saw that's 3D, Flutter's not involved, right? Because Flutter doesn't do 3D yet. But that's all done on the Babylon side. Yeah. But we've got a great design team that sat there and meticulously worked it all out and made them very large.
When you were talking about the perspective changes and the math and cameras and flight,
Yeah.
all those terms.
The homography transformations, yeah.
Yeah. Did you already have experience in that area, or did you have to like come up to speed?
Yeah.
During this
So the
project?
question is when we were talking about like the homography matrices and all the various different math stuff that we worked out, the cameras and blah blah blah. Did we have experience? Me personally, absolutely not. I had never heard of homography transformation before. I just thought it was magic when you took a picture of the document. It just was kind of there. I was like, oh, that's cool magic, or it's AI or something like that. It's not. There's simple math to do it, which is shocking. We have an engineer on our team that like I think kind of majored in math essentially, and so thankfully, right person at the right time kind of deal, just like the Starlink talk, just happened to come across it right and just do. And so she does a really great job at building a lot of that math stuff and teaching us how to do math and all that sort of stuff that's well past my knowledge. And then the Blender and the 3D stuff and how we use Babylon. Nobody on our team had ever used Babylon. I come from a web background, so I kind of understood it, but 3D on web was totally new to me as well. But it's just kind of the culture, right? It's the let's just find a path. It's not like, well, we don't have any Babylon experts, and finance says we can't go get another headcount to do it, so sorry, we're not going to do it. It's just we're going to figure it out. And this was before like Claude and all that sort of stuff too. So it was like a lot of, I mean, I think ChatGPT was around at that time, but we all know how ChatGPT is with code, especially back then. So it was a lot of just digging in, reading documentation, trying things, a lot of just trying. while there.
One of the things that's interesting, so I was at Visa for a while, and we wanted to build. This was the late 2010s. We wanted to use machine learning to figure out, or the product asked us to do machine learning to figure out how to read credit cards automatically and put them into our apps. But no one on our team had any experience, and it wasn't like they were willing to slow down. I don't think the culture was there to support like going down this like deep science path and learning all that. So that's kind of one of the things I'm curious about, like how much time do you have? Like how do you communicate? Like, hey, I have no idea what's going to happen. We're going to go off in this direction.
Yeah. So
product and design is just good with this.
Yeah. Question is like, you don't know how long something's going to take. How do you still have a roadmap, and how do you still do planning and product and everyone being okay with that? It's a lot of negotiating, I'd say. It's a lot of estimating, and it's a lot of running at times. I make sure we have really good life balance, like work-life balance. And so when we run, and when we play, we play. We take breaks, and everybody's working on features, so it's easy to kind of manage that schedule. But it is a lot of just like, okay, we got the design brief, we know how to do it. We take a little bit of a spike to kind of figure it out. We have an idea now. We think it's going to take n number of days or weeks, and we try really hard to make that happen. And we're really like all of the engineers on the team, they just want to build the best product possible and build amazing experiences like we saw, especially the ones that haven't been done, because that's super fun. And so they're just driven to do that. And it's just a culture. Once again, it's a lot of culture. It's kind of your point. It's like Visa didn't have that culture, so that's why you don't get that. It truly is about kind of the culture, and then allowing for this to happen. It has to happen at the team level. It has to be a decision everyone's making explicitly. You have to have a team that's saying, yes, we care so much about the experience, we're going to take the time to make it right. As I noted there, and that's the key. And if this was a super large organization and there was 100 developers, that probably doesn't work. But when you've got a smaller team or small pods, even within large organizations, this works. This works at large organizations like Disney and others, and it's because they've got small pods, and those small pods have this culture. Not every pod is like that at those organizations. I came from there. I worked there for about 7 years, and so you kind of see it. Some of them have it, some of them don't. It depends on kind of the product, what space you're in, and what you're trying to ship in. And of course, deadlines happen. And when deadlines happen, then it's sweat. But yeah, it's really truly about culture, and just if that's what you want to do, you've got to have the culture to do it. Yep. Cool. Anybody online? Questions?
Yeah, I'm checking. No, not seeing.
Cool.
Randall Schwartz is a longtime regular. He's I think he's a GE Flutter in Colorado.
Yep.
And he was asking if he can work contract. So I told him to reach out to you.
Yeah, reach out to me on LinkedIn. Yeah, he was up there. I'll put it back. But yeah, we're gonna do that for sure, right? There you go. Yeah.
Question.
Yep.
So if you work in a business where that culture isn't there, how do you, from like a leadership perspective, bring it out of the team?
So if you work at a company or an organization where the culture that I'm kind of talking about today doesn't exist, how do you, as a leader or a tech lead or something like that, try to bring that or try to influence? Is that the question?
Yeah. Or if they just like don't care about polish as much, they're just trying to ship something fast and work.
Yeah, I mean, it's hard. It has to be, you have to find the right time, first off, to try to introduce that into the team. You can't, do that when you're about to ship or you're working to ship or something like that. So you've got to find the right time. It's the same, I said this on the BGB podcast. We were kind of talking about like, okay, well, if your app, for example, is in Swift and Kotlin and you want to move it to Flutter or you want to move it to React Native, how do you do that? Well, you find the right time. Like a lot of the engineers in large organizations, they're just bringing up ideas because they saw this talk or they've heard that podcast and they're like, this is really great. We should do this. It's not the right time. And trying to find that time to do that is important, and it's hard. The other thing is it's a team decision, it's a culture change, and change is hard. No matter what type of change, it's really hard. And so some of it is just like you have enough influence and you find the right people to get and gain that traction of influence, and then some of it's just organizationally and company wide. Or if you're in pods, then the pod. Um, it's going to implement a lot. It's going to require a lot more technical challenges, as we talked about, and some of that needs time, some of it doesn't. Um, but yeah, it's not easy question to answer. I got really lucky that I kind of came into Foresight and we were redefining software, and so we started with this as the culture, and so it was a lot easier to do something like this. But it's also the time. Like that was the time to do it because we were redefining what we were doing with software, and so that meant we could challenge everything, including the culture and how this team operates and whatnot. Um, and I think that's probably to answer your question is finding the right time. Unfortunately, it may never come at that organization because of organizational level policies, and that's okay too. That's why we have personal projects, right?
But like, how do you manage deadlines over quality of the product?
How do you manage deadlines over the quality of the product? You slip, you miss sometimes. You miss a deadline,
Yeah.
and I, as a senior director, have to go report that back up, and we have to just understand. Okay, it's like, well, I get it. It's 100 milliseconds off, and trying to figure that out that last 100 milliseconds, or trying to figure out that last 30% or whatever it's going to take this X amount of time. Maybe we ship and we fast follow. That's acceptable as long as we're going to fast follow them. What's probably not acceptable is calling it tech debt and then throwing it into that bucket that we call tech debt and never getting to it, right? So it's those trade-offs. It is business decisions at the end of the day. Running a business, right? And you're delivering to customers and you have expectations and realities. And so sometimes something is going to give and something has to give. The question is everyone on board with this or that? And then it's ensuring that you don't sacrifice your culture to do that. So that means going in and setting up that fast follow or something like that. That's not sacrificing the culture. Saying, oh, it doesn't matter, that's sacrificing the culture. And it's a slippery slope because then you don't get it back. And it's really hard to do that. Maintaining this culture is really, really hard, but it pays dividends. And we continue to see that. And when you see it pay back, you have that want to continue that culture. But if you start slipping, it's just like habits, right? I forget the term, but it's like building a habit takes like 4 weeks or something like that, but breaking it takes 3 days. Same concept. Yeah, it's really hard. But once you're in, just keep the cycle. Cool. Yes?
Sorry, last question.
No, you can have 100 questions.
Okay, going back to the Flutter code real quick. I assume you all have a state management choice that you use?
We do, yeah.
I'm just curious what that may be.
Yeah.
So,
because you asked, I'm going to put you in the hot seat. I do this in my interviews. The question for those online was, you likely have a state management interface, and what is the one that you choose? So when I'm interviewing candidates, I love this question. I call it the elephant in the room. So everyone has an opinion on it, and everyone has different reasons for picking their preferred state management. So I will tell you mine if you will tell me yours. And I'm not going to say mine first because I don't want your opinion to be biased.
Okay.
I'm so sorry, I forgot your name.
Trey.
Trey. All right. So Trey is going to share his preference when he starts up a new project of what state management system he prefers.
So typically it would be block. But I've now been experiencing signals.
Signals.
And
okay.
It's much more simplistic.
Yep.
I don't know how to explain it fully.
Yep.
But it's much more readable, and I've been kind of going down that lane. So
yeah. So block, but you started experimenting with signals.
Yeah.
Really like it. You don't know why, and it's because it doesn't work. It feels right. See?
Yes. That's a great callback.
You can't explain why, but it just feels right.
Exactly.
Cool. Yeah. So we tried all of them. Every single one. Signals wasn't around then. So we had a great opportunity to come in and redefine software, as I talked about. We came in and there was an app already built in React Native. And we looked at it, and not because of React Native, but just because of some other architectural decisions and kind of where we wanted to go, we started Flutter. We had some experience with Flutter from some other projects that we kind of came from, blah, blah, blah. And then we said, okay, well, we've used this state management system before, but rethink everything, right? Like that's kind of the whole mantra here is just like rethink everything. So we tried them all. Provider, Riverpod, Block, Get, X, like all the big ones. And I've got a document, a Confluence document that I could share. that's this long on all the various things. And we ended up with Block asterisk. Block is really great for huge ambitious apps. And I think that's what drove us that way, because we can break things up, because they can have their own specific abilities. You're not loading global space with some of the other ones and various other issues, and the way that it orchestrates. And I say asterisk because we use Block a little bit differently than what the documentation tells you to do. First off, we have an extension on the class Block called Superblock. And Superblock adds in a bunch of things, niceties that we really like. Logging when block states, block events happen and stuff like that, which Block may have today, but we upgrade, but we don't upgrade all the time. Flutter upgrading is hard, as you guys know, but it's getting easier. We've got some other various other logging things, and we've got there was a way to like wait for a block event to finish. It existed in like an older version of Block, and then it went away. And I know you're not supposed to do that because that's not the point of Block. Block's like a fire and forget. If you want that, get a qubit kind of thing, right? But we were already in Block, and we kind of wanted to do this thing, so we added that. But the other change that we made is I come from a web background. I come from Redux, Onyx.js, those sort of state management systems. And what they have is they have a single state, and they have events that you fire, and then the state gets modified. So if you're loading, you just look at the state. Loading is true or loading is false. You don't look at if the state is this class type. It really just kind of bothered me that I needed switch statements throughout all of my very pretty Flutter code. So we have one state. It's freezed. It's a freezed object. We use freezed everywhere, immutability through the wind. And then we have a bunch of events. And then when we do something inside those events, we emit the state.copyWith. And we just modify the state. So we have one state throughout the entire block, and we just modify the properties on those blocks. And then if I want to do something in my UI, I look at the property to do the thing in the UI. I don't look at what the class type is. That's a huge thing for us. And so we get all the niceties of blocks, the concurrency, like all that sort of stuff, and we get like a single state object. And I look forward to everyone telling me why we shouldn't do that, or why we should, or whatnot, or hey, that's what this thing does, blah blah blah. But it's kind of where we landed. We're really happy with that. It's worked really, really well to develop this ginormous application that we just kind of looked at the top of the iceberg of. But that's my answer. Block asterisk.
Nice. I like that.
Yep.
Thank you.
Not a sponsor, but could be. All right. Anything on web? Any other questions? Am I getting a bunch of feedback now on our block decision?
No, they're talking about Signal a lot.
Oh, Signal. Yeah, we have signals too, but we don't have Signal. We have Signals, which is kind of like the system that we built before Signal, that like lets us like listen to signals essentially based upon them. So we had that from a while back when Signal didn't really exist, and super helpful for like firing off events inside this feature and other feature listening to it and whatnot. We don't love cross pollination, and so like feature listening to another block's feature is like a no-no for us. And so we use signals instead, because then the logic still lives in this feature to handle that signal, versus like the block still being over here. So yeah, nice separation of concern there for us. So yeah, we use a little bit of that, just not as in depth as signals is in depth.
Randall asks, how do you get fine-grained notification only on one parameter if all you have is a changing object?
Yes, so the question was from Randall, how do you get fine-grained control over like UI state change when you only have one object that's changing? The build listener provides a build when, or something like that, that you can look at equatable differences. And so since they're freezed objects, they get equatable by default as well, which is fantastic. So if we're only going to want to change the UI based on one property, we just do the check there. Then the build method doesn't run unless that check actually returns true. So it's a lot of leaning on that. So yeah, it's a little bit of extra work
something that we can like download and use ourselves?
Sorry. No, it wasn't because of the question. This timing, everything's fine. So I've thought about that and thought about like opening sourcing this presentation model, and I will continue to think about that. I think it's a super cool way to show off Flutter. It does require your app to expose things. It's nice because it's done all throughout the app, but like I was calling block events and stuff like that, right? Like that's how we automatically got to screens behind the scenes. Like the screens, if I showed it the whole time, we're moving around because we're calling block events and stuff like that. So if you're not already positioned to like do that or expose your router through a repository layer or something like that, you're gonna have a hard time. But generally speaking, it's pretty good. So yeah, like I plan to get like this kind of thing open source. It's more effort than a Keto for sure. So just calling that out or PowerPoint, but I mean, I think it speaks volumes. So, but yeah, the intent is definitely to put it out.
Cool.
Yeah.
Great presentation. Thank you.
Thank you. Yeah. For sure.
If you need park or anything, please come see me for pass, and then please do get registered on GDG. We do have more events planned for the next few months. Hey, that was great. Yeah.
Oh,
No, that was really good. So is that what you're gonna do at FlutterCon?
Yeah. So FlutterCon, there's
I live in Dallas. I actually drove.
Oh, where?
Yeah, I have a friend out here.
Yeah, that's great.
Yeah.
So for me,
So,
like, super deep in,
how
but
long have you done?
I'm still gonna do this
Since
system.
December of 2024.
Is it just like
But about a year and a half.
Y'all are smooth.
yeah,
I like
but no,
that.
this one is
I'll
this
go-
is
I'll
the
go
same one I've been
up
to.
there. I can go up there.
Yeah, it's nice.
Yeah, that'd be fun.
I live in like
There's a little shelf full of my
areas.
other books and a bunch.
I know. You're getting active out there,
I
aren't
know.
you?
Hey, TBD.
You should do.
Yeah,
You should do
I
it.
work for
I'm
Like,
talking to
consultancy.
Optimal.
BGB was doing their own
Optimal. The Flutter product.
still like
I
trying
don't know.
but yeah,
I also don't pronounce it, but I'm meeting with him. I've already met with him a bunch, so I'm going to meet up with him at Flutterflow because
yeah, you'll get like IO tickets and everything.
yeah, we want to because what I told you about the device, I want a case study, or I want to try to get a case study because yeah, it's radical. But yeah, we'll schedule something maybe if you guys want to do November.
Dude, it's
December.
cool. It's like I feel like Flutter right now is like I was just telling you like I know it has all these capabilities, but I haven't seen it as a lead on the market until like now. Like over these last like 3 to 4 months, like I'm seeing so many just really crazy Flutter roles, like intricate, embedded, privacy stuff, desktop, like all of this crazy stuff.
I want spilled everywhere.
I'm curious.
Yes.
For the golf fanatics, are they actually using this just for the fun, or is it helping them improve?
Actually, yep.
And they feel like it, or they can prove that it's
Yep.
helping them?
Yep. And that's like where our history and all that sort of stuff comes into play. So like at the end of the training that was running there's 4 graphs. So if you go, you get like all this history of like how you've been doing over time. And so we provide that. The tour pros know what these numbers mean. So like they just look at the screen all day long and they know like, oh, that site's been up like 4,000 RPM. That's the reason why, and they know it's because I just needed to move this like a microsecond. Yeah. So, but yes, like I have personally not taken any golf course lessons, any lessons at all. I've been focusing on just learning through our software experiences because I think that's the best. If like I still never
I'm sorry.
technology
I'm sorry.
to golf, then I've won, right? Like I've solved what I can solve.
And I've been to Detroit.
That's the problem with scope creep and possibly use for
I love it.
I love it. The ball, yeah.
So you can't, because one, it'll make it heavier. So much about the golf ball's weight. Two, the PGA would always freak out. Now you also can't use the club head, but what they've been doing is this area here of the shaft, they'll put a device, and that will measure all of this, right? So it's like it's geo based. So the shaft itself, like this grip, gets that addition onto it, and then as you can imagine, it goes exactly what happens with the club. It doesn't know what happened with the ball, but it knows what happened with the club, which is cool. This is the only way to get that ball picked up. Yeah. They have tried to get electronics into the ball. The weight is the problem. Batteries are heavy. Batteries are heavy. So, and then how do you charge it? And after you
electric from the impact.
yeah, right.
Temporary burst of data.
And then the other issue is how do you transmit that data? The ball is now 400 yards that way, and it moved really fast. There's so many challenges.
Later, man. See you next time.
See you, Trey.
Yeah, no, appreciate it. Thank you.
Yeah, if any of you guys want like 4 sandwiches.
It's pretty cool.
To see a lot of that.
Yeah.
And then see the actual.
Yeah, you never saw the device, right? Yeah. Yeah.
How long have y'all been developing the Flutter app?
2 years. As of next month, I think it is.
But now what you were showing was like a recent thing that's been out.
Yeah, so we launched a year ago, and training, ClubView released like 2 months after that.
Okay.
Training released
Yeah, Jordan?
a month ago or 2 months ago.
So what you were showing is not shipping one big thing.
Which is really hard to do because we took it. We were in a good spot. We used an app that did pretty much nothing and did really badly, and replaced it with that, and that was fine. We just need to get there and get after launch, and then it was like, okay, let's add new things in now.
I almost bought their litter box.
Yeah. Oh,
Yeah.
yeah.
$1,000, dude. I was like, I don't care about
Get the four. Yeah, get the four. Get the
Yeah, you
four.
should,
Well, then now it's like, I was
Flutter
looking on the
because
website.
it's a perfect, like my question about like if you run into anything.
Yeah.
Consistency, and I was like, okay, I don't need all of that.